Talk about dissociation. Dissociation we touched on a little bit when we were in our solutions unit, and the dissociation just means that when you put an ionic compound into water, it's going to break apart into its ions. And so the water breaks it apart, it goes back together when they bump apart or bump it into each other, they go back and forth and back and forth and back and forth. So as we look at our dissociation, we're going to look at different types of acids, and we're going to look at the strength of said acid. So the first thing we need to define before we get to that point is polyprotic acid. Poly means many or multiple. So your polyprotic acid is just one that has more than one hydrogen present. Monoprotic would be a single. Protic is proton, so that's a hydrogen ion, so a single ion present. So looking at this polyprotic acid, there's actually a few different types. You do have your monoprotic acid. Monoprotic would just have one hydrogen. So an example of that would be like HCl. So if you have hydrochloric acid, you have one hydrogen and one chlorine present. Hydrofluoric acid would have one hydrogen and one fluorine present. Diprotic acid, your diprotic means two. So that would mean that you have two hydrogens there. With your two hydrogens, that would be something like, sulfuric acid. Sulfuric acid has H2SO4, so there's two hydrogens there. A triprotic acid, tri means three, so that means that you have three hydrogen ions present. So that would be something like phosphoric acid. If you have phosphoric acid, it would be H3PO4. Now, the reason why we're talking about this is the fact that each time you have that hydrogen, it bumps into water, it pulls away one of those ions, one hydrogen. So we talked about the fact that the acid donates away the hydrogen to the base. As you donate away the hydrogen to the base, if the base bumps into it, it takes away that hydrogen and it moves it away. The strength of the acid is relevant to that because the quicker that an acid can get rid of all of its hydrogens, it can only get rid of one at a time, so each time it bumps into something, it takes it away. But each time that it bumps into something, it gets rid of one hydrogen. So the faster it can get rid of all of its hydrogens, the stronger the acid. The more steps that it takes to get rid of that hydrogen, the weaker the acid actually is. So if you have something like hydrofluoric acid gets rid of its hydrogen in one step. So because it gets rid of its one step, it's a very strong acid. If it takes more than one step to get rid of its hydrogens, then it's going to, that says reactions, it's not really a reaction, but it's going to take more steps to get rid of its hydrogen, so it is a weaker acid. But it can only get rid of one hydrogen at a time. And with your dissociation, what we're going to do is we're going to show the fact that the hydrogen gets taken away, because acids get rid of hydrogens, they are losers, and then we're going to show what's left. And then that's going to bring us right into dissociation. So with this, we're going to show how we get rid of all three of these hydrogens throughout the, my document camera is not set up. There we go. So we're going to show how we can get rid of each of the hydrogens one step at a time. So if we have something like H3PO4, we can show the fact that we're going to get rid of our one hydrogen atom. Ion, not atom, sorry. And as we get rid of our one hydrogen ion, we're going to show what else is left. So we're showing that this is going to something else. We don't really care where it goes at this point. It is going away. Then we're going to show what we have remaining. So if I have H3PO4, so with my H3PO4, I'm getting rid of a hydrogen with a +1 charge. So we can kind of think about this as I've got 3 positive charges. PO4 has 3 negative charges, that's phosphate. If I get rid of hydrogen with a +1, one of my positive charges goes away. So I'm left with H2. That anion, PO4, is still there. Now I'm left with an overall charge, like this one and this one are going to cancel, this one and this one are going to cancel. I have one negative charge that doesn't cancel, so I'm left with a -1 charge. Now this guy is floating around in the solution. Let's say that this guy bumps into a base. So we're going to start with this one next, H2PO4 minus 1. And we're going to show what happens when this guy gets rid of a hydrogen. So that guy, H plus 1, that proton, goes to something else. Again, we don't care where it goes at this point, it's just going away. And we're going to show what's left over. So if we get rid of another positive charge, I'm left with H, there's only one of them left, PO4 -2. Because these two are canceling, that leaves me with two negative charges that don't have anything to cancel with. But this guy still has a hydrogen. With this guy still having a hydrogen, it's floating around in the solution. It can get rid of that hydrogen also. So we're going to show what happens when it gets rid of that hydrogen. So I'm just rewriting it down here to show what happens here. Again, my hydrogen with a +1 goes away. Goes to something else, don't really care. We're going to show what's remaining. So we got rid of hydrogen with a +1. So we're left with PO4 with a -3 charge. He doesn't have any hydrogens to get rid of, so this is completely going through dissociation. It takes 3 steps to get rid of our 3 hydrogens off of our initial H3PO4. Now you can also just do this in a single step, and it might say, hey, we have HClO4, what's the conjugate base? So it's basically asking you to do something like this, because remember, acids make conjugate bases. So we're going to show what happens when it gets rid of a hydrogen. So right now we've got HClO4, it's overall neutral. So this hydrogen is going to go to something else. So we're going to show what's left over. And we're left with ClO4, and that's going to have a -1 charge because I'm losing hydrogen with a +1. Again, that's going to go away. We're not really showing that in this case, but we're just showing what's left for your conjugate base. Now on this one it says, hey, we've got a base. What's the conjugate acid? So in this one, the bases are the ones that accept in the hydrogen. So if we're accepting in the hydrogen, we're going to add a hydrogen to this Cn-1. If we add a hydrogen, remember hydrogen is always written in the first spots. We have HCN. I'm adding hydrogen with a +1. This guy has a -1. Those two are going to cancel out when they come together, so you're just left with HCN. So in these, there's a few different ways that they can ask you to about your dissociation, but you're just showing the fact that you are gaining or losing 1 hydrogen each step of the way. If you have an acid, you get rid of 1 hydrogen each time, or it might ask you what's the conjugate base or what is the conjugate acid for whatever is given to you in the solution. I hope that helps. If you guys have any questions, make sure that you ask.